Okay, we're taking a look here at why you would use a system of inequalities. We've been doing graphs of these things for a while, graphing one inequality and two inequalities, and look and see where they cross and see if a point fits in the solution and that kind of stuff. But why would you use this stuff? So I'd like to take you through something like that. I'm going to pause at different times and ask some questions like I would in class. If I put it on Edpuzzle, then you'll be able to answer questions as they pop up. But I wanted you to be able to see how you'd use this stuff. So I want you to consider the Built Right Furniture Company. And they make chairs and desks. And for right now, I'm just going to tell you it takes them 2 hours to make a chair and 5 hours to make a desk. Okay? So how long would it take them to make 15 chairs and 22 desks? So we'd pause there and I'd ask some questions in class, and you'd figure that out. So I'm going to give you a chance to do that. Okay? So I imagine that you did something like this. You said, well, if it takes him 2 hours to make a chair, that's going to be, let's see, 2 hours for each chair, and there's 15 chairs. So if you multiply 2 times 15, you get 30 hours to make chairs. And then you've got to multiply 5 by 22 to find out how many hours it takes to make the desks, and then you add them together. Well, I encourage people to use something like this, where if you're using a scientific calculator, it will leave the math on the screen for you and then put the answer there for you. So here's the math doing that. You could just type 2 times 15 and get your answer, and then type 2 times 20 or 5 times 22 and get your answer, and then add those two things together. But it makes sense to me to just leave the thing on the screen that way and get your answer. So it's 140 hours. Okay, so I want to go on now. It turns out that this company has 7 workers, and they can each work 40 hours a week. Okay? So if they've got that amount of time available for making chairs and desks, could they make 70 chairs and 15 desks in a week? Okay? And then how do you know? Okay, so take a minute, think about that. I would have you in class maybe write that on a whiteboard, on a piece of paper, think about that, and then we discuss our answers. Okay, so what we've got to figure out is this: if it takes them, if they're going to make 70 chairs, okay, that's going to be 70 times 2. That's going to be 140 right there, just making the chairs. And they've got to figure out we've got to figure out what 5 times 15 is. Sorry, yeah, 5 times 15, and that's the number of hours it takes to make a desk. And then is that over the total amount of time? Well, what is the total amount of time anyway? Well, 7 workers at 40 hours a week, 7 times 40 would be 280 hours a week available to make chairs. So let's check and see, does 70 times 2 plus 5 times 15, is that over 280 or not? So let's check our calculator here. Okay. We had 70 times 2, oops, and 15 times 5, okay, that's 147. Well, that's below 280. So the answer is yes, they could. Okay, sorry, here's the right page. Yes, they could make that many chairs and desks in a week based on the fact that they've got 280 hours a week available, and it was only 147 hours to make all these chairs and desks. Okay. So what I want you to do now is give an example of a combination of chairs and desks that they could not make in a week because it would take them too long. Okay, so just make up some numbers. You could be as ridiculous as you want, but the idea is make sure that the total amount of time goes over 280. Okay. So I hope you picked something. I mean, you could, like I said, you could pick pretty much anything. If it's, oh, I got that wrong. There should be a multiplication here. Okay, good. It's still under 280. I had that wrong there. So in class, somebody would have caught that, but that's a disadvantage of distance learning, huh? Okay. So what number of chairs and desks could you pick to go over 280? Well, pretty easy. If you make this 100, for instance, you're at 275, so we're almost there. So I don't know, how about make this 30, and now we're above 280. So 100 chairs, 30 desks would go over the top there. Okay. So So the next thing I want you to think about is this. What does it have to do with a system of inequalities? I mean, we're talking about chairs and desks here, not inequalities. Well, I want you to think about this idea as well for this company. Okay, so not only do they have to make the chairs, they've got to finish them. Okay, they got to do sanding and painting and things like that. So they've got 3.5 full-time workers. Okay, 3 workers and a half a worker. Maybe one person works half-time for finishing, and it takes them an hour and a half to finish a chair and 2.5 hours to make a desk, and so now they've got another limitation basically. And let's see, 3 hours for full time. 3 hours at full time, that's 120, plus another 20 hours for half time, that's 140. So now you've got to think about the number of chairs and desks that you're going to make. Does it also fit this? Okay, so I'm going to ask a question here. Let's see. Here's my question. Okay, could they make 70 chairs and 15 desks now? Okay, well, we already know they can make 70 chairs and 15 desks if we're just talking about making them, but can they also fit within this requirement of not going over 140 hours at 1.5 hours to make a chair and 2.5 hours to make a desk? Okay, so think about that for a bit, and then I'll get right back to it. Okay, so let's go back and look at our calculator here. What we need to do now is multiply 1.5 times 70 and 2.5 times 15 and see if I go over this 140 hours that they've got available for finishing. Okay. So let's do 1.5 times 70 and 2.5 times 15. 1.5 times 70 plus 2.5 times 15. Okay, look at that. They had 140 hours available, but 70 chairs and 15 desks goes over that. Okay, so the answer is no. They can't actually make that many chairs and desks. Okay, so what you're probably noticing is this. This is getting complicated, and it'd be nice to have a better way to keep track of what they're doing here. Okay, well, what I'm going to do is build an inequality first that has to do with the making the chairs and desks. Okay, so let's do this. Let's ask this question: could they make 80 chairs and 12 desks? Okay. Well, you would multiply the 2 hours it takes to make a chair times 80, and you'd multiply the 5 hours it takes to make a desk times 12, and you'd add that together and you'd say, look, I'm hoping that isn't bigger than 280. Okay, so I'm going to write that. Okay, I'm going to hope it's less than or at least equal to 280. Okay, well, what if I change the numbers to 60 chairs and 40 desks? Okay. Well, isn't this going to be the same math I do, except this will be a 60 and this will be a 40. Okay. And then I calculate and see if it's true. Well, what if I change it again to 30 chairs and 100 desks? Okay. Well, I would say 2 times 30 and 5 times 100. Okay. Does that go over 280? And of course it's going to, because 5 times 100 is 500. Okay. But here's the deal. What I did there was I wrote down some math that I was doing to answer this question, and I said, what if these things change? Okay. This is a great way to help you build an inequality, because you can say, look, what if instead it's X chairs and Y desks? Well, you just replace these numbers with X and Y. Okay? So your inequality would be 2X plus 5Y is less than or equal to 280. Okay? And what I want to do is graph that and show you what it looks like here. So let me step over here to the graph. Here's a Desmos graph, ready to go. So 2x plus 5y, and then to get less than or equal to, you can either bring up the keyboard on Desmos or just type less than and then an equal to sign that sticks it right there, and then 280. Okay, so this inequality right here is describing all the locations here in purple are combinations of chairs and desks that you could make and stay below 280. So this would be 30 chairs and 30 desks. You can do that. This would be 70 chairs and 20 desks. You can do that. This would be 70 chairs and 40 desks. You can't do that because it's outside the inequality. It goes over 280. Okay? So here's what we're going to do. I'm going to ask you this next question. Okay? Given that they have 140 hours available for finishing, and it takes 1.5 hours to finish a chair, and 2.5 hours to make a desk. Okay, what inequality describes the finishing part of this business? We already have an inequality right here that describes the manufacturing, the building part of the business. But what's an inequality that describes the finishing part of the business? Okay, well, we're going to do the same kind of thing. We're going to say, look, if you asked me about, say, 40 chairs and 50 desks, okay, I would do this. I'd say, well, what is 1.5 times 40 and 2.5 times 50? Let me be consistent here and put this in a set of parentheses. So what are these two amounts, 1.5 times 40 and 2.5 times 50? And when I add those together, does that go over 140? Because that's how many hours I had available. Okay, well, yes, it does. Okay, but what I want to point out is this. If I now go back and say, what if there are X chairs and Y desks, then we'll just replace the 40 with an X and a 50 with a Y, and I got my inequality here. So 1.5 times X plus 2.5 times Y is less than or equal to 140. Okay? So that is that's much easier than trying to guess and check and see, like we did up here. Could you actually do this? Okay? By putting the numbers in and calculating every time. What I can do is say this. Let me put this on the graph, and you'll see different combinations that you can and can't make. Okay, so go back to the graph, and we'll type in 1.5x plus 2.5y is less than or equal to 140. Okay, and so now you can see combinations that fit into both of these. Okay, so now you can see that combination. Back when we did 70 chairs and 15 desks, if you look on the graph here, 70 and 15 is going to be right about in here, and as you zoom in, oh, it doesn't actually fit. It was close, but it doesn't fit. Okay? Now, here's the great thing about this kind of stuff. Suppose somebody comes along and says, oh, you know what? We screwed up. It turns out it takes 8 hours to make a desk. So I'm going to go back here and replace the 5 with an 8, and notice that it changes my graph really quickly here. But it's easy now to continue seeing spots where, hey, in here, it meets the purple criteria. I'm sorry, the gray criteria, but not the purple one. Okay? In other words, you could do that amount of finishing, but you couldn't do that amount of manufacturing. Over here, here's a combination that fits into the purple, so you could do that amount of manufacturing, but it's outside the gray one, so you can't do that for finishing. So this makes it really nice. It's especially nice if somebody comes along and says, wait, we need to make at least, say, 40 chairs. Okay? So I'm going to type X is greater than or equal to 40, and that puts a new inequality on there that describes the fact that you can't, you have to make more than 40 chairs. Okay? But what if somebody else says, hey, wait, but we also need to make sure we do less than or equal to 65 chairs. Oops, got that wrong. Okay. So now we've got it more shading in here, but this sweet spot right in here is the place where we could have all these different combinations of chairs and desks that you could manufacture. Okay? There's an easier way to write this. If you put the 40 right in front of this and make it less than or equal to, okay, and then I can delete this one. This kind of cleans it up a little bit because it just makes this blue band in the middle here that describes the minimum and maximum number of chairs. Well, you could do the same thing with desks. If someone says you got to make more than 10 but no more than 30 desks, you could say, okay, no problem. 10 is less than or equal to y, which is less than or equal to 60 or 30. Okay. So that describes being able to do above 10 but below 30 chairs. I'm sorry, desks. So what you're getting is a sweet spot right in here that describes all the combinations of chairs and desks that you could make based on the limitations you've got. And being able to visualize this using these inequalities makes it much nicer to be able to keep track of what you're doing. Okay, so now I can ask you a question like this. Please find me a combination of chairs and desks that meets this criteria, that stays below the number of hours of manufacturing, below the number of hours of finishing, and is within our limits for chairs and within our limits for desks. Okay, so pick a point, type it in, or hold it up on a piece of paper, whatever we're doing in class. Okay, so basically, what you did was find some point inside this this region right in here. Okay, and hopefully you found one that meets all the criteria. It's way easier to tell on the graph than it is to put those numbers that you chose for x and y in for every x and y in each of these things and figure out whether it works or not. Okay? So I want to show you finally why this is really important in the business world. Okay? Suppose that somebody says, you know what, I make $10 for every chair and I make $30 for every desk, and I'm wondering, given all these limitations, could I make $1,000 a week? Okay? So here's what I'm going to do. I'm going to write an equation. And we would practice later or another time on how to actually do this. But $10 times the number of chairs plus $30 times the number of desks equals 1,000. Okay. Okay. And so here's the question. Does that combination fit within our graph? Well, yeah, right on this line right here that represents the amount of money we're making, that does pass through our region of possibilities here. They call it the feasible region. So this region here is all the possible combinations, and there are lots of combinations along here that you could make that fit that criteria. Okay? Let's ask this question. Could I make $2,000? Okay? No. You see my line went up here? All the possible combinations are in here, so I can't make $2,000. Maybe I could make $1,500 though. Let's try it. Nope, doesn't look like it. Could I make 1,100? Yeah, I can make 1,100. Okay, because that goes through this region. Could I make 1,200? Wow. Yeah, looks like that combination right there is the only combination that you could make $1,200 on. Okay, so now we know not only different combinations that we could feasibly make, but we know the combination that makes us the most money. Okay, now here's another question. What if it turns out I make only $25? Okay, so now that changes it. Okay, because it's not within this region. So we'd have to go back down here and say, well, maybe we can make 1,100. It looks like it might. Can we make 1,000? Yep, there's several combinations. So this math isn't designed to make you feel bad about yourself. It's designed to make it easier to keep track of what you're doing. So what I want to show you last is this. Okay, please don't freak out when you see all these words. Okay, here's the description of a bicycle company that makes basic and deluxe models. Okay, basic and deluxe right here. Okay? And it describes all the stuff that they've got to keep track of. Okay? It turns out they have to manufacture the things. Well, let me back up here. They got to manufacture, they have to assemble, and they have to tune all of them. And all this information describes how long it takes to do each of those things and how many hours they've got available. Well, trying to keep track of that, just trying to manage it in your head would get really ugly. But here's the cool thing. If you look at a graph of that situation, okay, here it is. Okay. By the way, one of the combinations, or one of the things said, hey, you have to make at least twice as many basics as deluxes. Okay. So this region right in here, this triangular region, is the region where all of them are shaded, which means you can make any combination inside here and still be able to meet all your criteria. Of course, the goal is going to be to find out which combination makes you the most money. Okay, and it turns out it's either going to be at that corner or that corner, because those are the highest ones. Maybe that corner. Okay, we'd have to check and see how much money you make on each one. Okay, but this allows you to visualize what's going on much more easily. Okay, so that's the whole idea behind writing in a system of